today with me, I have Pavol Gressa here. Pavol works on the Micronaut team at Oracle Labs, or maybe at Oracle. Pavol, how are you doing?
I'm well, thanks. How are you?
I'm pretty good. We have two major topics today. Micronaut in the Kubernetes, which is for me a very exciting topic because I know a little bit about Micronaut and I know much less about Kubernetes, right? So it's we're gonna explore this combination. So we're gonna try to build some services and we're gonna try to put them into Kubernetes, and we're gonna build the services using Micronaut because it's a very cool application framework, and because we have Pavol here, who is an expert in all things Micronaut, putting you on the spot like that. And he has been working with Kubernetes for at least a little bit. So he will try to teach me some things and I will try to learn, and hopefully this will be useful for other people as well. Right, so Pavol, right, tell me maybe a couple of lines, a couple of sentences about what you do at work and how you stumble upon this particular combination of Kubernetes and Micronaut.
Yeah. So first, thanks for invitation, Oleg. That's definitely a place to thank you for this opportunity to basically, present you Micronaut and what I do. Well, as you said, I work in Oracle, in specifically the Oracle Labs, where we are trying to develop the best microservices framework with Graham Rocher. I believe he was your guest also a few times before, so I believe that the listeners are aware who is this guy. So I work with him, and it's quite a challenge, and also it's a lot of fun to work with Graham. And yeah, how I ended up, well, there are moments in your life when you know that something interesting is going on, and I met Graham, and he just told me like he would like to work with Micronaut in Oracle, and he asked me whether I would like to join, so I joined, etc. So I'm now working on Micronaut for almost a year. It's a lot of fun. As you said, I was working with Kubernetes before in my previous roles. So Kubernetes, it's not something I didn't know before. So what I'm trying to do now is to take all my experience from using Kubernetes to Micronaut framework and to improve the support and the integration. It's good to say that the Micronaut is quite young framework, and the Micronaut and the Kubernetes module is much more younger. So we are still trying to improve this module, and if any listeners are basically using Kubernetes module, then in Micronaut, then just find some missing features or find some bugs. So just please, guys, file an issue, and I'll try to do my best to fix those stuff or create some new features.
Excellent. Right. So without further ado, let me maybe talk a little bit about the setup here, right? So because I've come prepared, I don't know a lot about Kubernetes, but I've looked into the things, and I have my cloud machine here, the virtual machine that I'm using for my demos, and I installed a Kubernetes. I installed Kind, which is the tool that can create a local Kubernetes cluster for me, and we're gonna use that one if we have at least the opportunity. Right, so of course, in any cloud, you will have the managed Kubernetes service, right? But I wanted to keep this as simple as possible for myself, right? And it's sort of a little bit neutral, not to go and say like, oh, this is possible only because there is a managed Kubernetes engine somewhere in the particular cloud environment. So this VM is, of course, in the Oracle Cloud. And it's a fairly powerful machine, right? So it has eight cores, so that's 16 threads. It has 100 gigabytes of RAM. So this is my workstation I assume that this should be enough to kind of maybe deploy a couple of small services and explore how it works all together. So yeah, and from this moment you are in the driver's seat. So tell me what to do. I will go to my streaming setup, live streams, and this will be our working directory here.
Okay. So to just briefly describe what we are planning to do now is, as you said, to create a microservice and deploy it to Kubernetes, and to use some of the features of Micronaut Kubernetes module. So I will just very briefly, highlight what the Micronaut Kubernetes module is capable of, but we won't have the time to present all of it. So maybe next time we can look to other features. But to just highlight some of the things, then our Micronaut Kubernetes module basically what it can do is service discovery. Naturally, in Kubernetes you have native service discovery by internal DNS, but for that you need to, for example, state all the service name if you are accessing through other namespace, etc. But what we do, for example, in Micronaut is that we are downloading all the metadata from services and from endpoints, and we are combining it and allowing the users to drive the service discovery themselves if there is such a demand, right? But by default the service discovery works. Then we have something what we will be actually presenting today, and it's a configuration discovery. What means that as you are aware, Micronaut when Micronaut starts, you can configure the Micronaut by using application YAML files, and many times, if you have like 10 services running in Kubernetes and want to, manage the configuration for these 10 services, then you can create one config map, and in this config map, you have like basically distributed configuration. So this is something that what Micronaut Kubernetes is capable of as well. Of course, there's some secrets discovery. So secrets are key part in managing integration with other services, right? So you can, provide the services, provide the secrets to the service through the Kubernetes secrets. And there are also some other features, like we have like official Kubernetes integration. It's quite new feature at this moment. So what I mean by that, well, Kubernetes, there's some official Kubernetes Java SDK, and we added support for it the way that you can inject the Kubernetes API's object as regular beans, or they are already configured. So you will just add a module, and you can like a dependency to this module, and you can automatically inject the Kubernetes SDK APIs. And of course, we plan a lot of other things to do. So we are planning to integrate and add a support for Kubernetes operators. So it will be quite easy to write Kubernetes operator in Micronaut. So that's very briefly about what we are basically capable of and what we plan to do in Micronaut Kubernetes. And now back to the application. As I mentioned, we will create a microservice. We will deploy this microservice to Kubernetes, and we will present this configuration discovery. So first, Oleg, let's start. You aware how to create a microservice using Micronaut CLI tool?
Yeah. I have the Micronaut tool installed. This is of a modern version, 2.4.1. I think this is actually the latest. And I just do Micronaut create app, and I will call it demo, like maybe demo app.
Well, you have to put the package name there. Never mind.
Yes. Wait, remove the demo, and we're gonna do the org. I'm not sure if this is the correct package, but we'll have that. So I have this demo directory, and I have my auto commit running. So if you do the exclamation point repo command in the chat, you will get the link where this application should appear kind of soon. So I can get into this, right? And I can add a controller. It's going to be a web application, right? the Kubernetes operates on the...
Gonna be, yeah. So add some simple controller.
This Micronaut create controller example, right? Example, maybe example. Example controller test. I think that should be fine. So I can Gradle W run it or build it.
Yeah.
Right?
You can build it, run it, or run tests. The nice thing about this Micronaut CLI tool is that it basically generates you the subject and even the test of the subject.
Right. So I've built it and it builds, and I also can let me just run it because I think this is the simple thing that I can do. And we're gonna I want to test that it runs. I know that this is kind of sort of a simple and maybe not the most sophisticated test, but I'm gonna localhost 8080.
Yeah.
And example. It was example, right?
Oh, I believe so.
Right. So we have example response. I have this little curl trick. Curl trick that I can do. Example response. Very good. Our service is operational. This is our Guinea pig application, and we can then try to throw it over the wall into the Kubernetes cluster.
Well, first we have to, the main package that we deliver to Kubernetes is Docker container, right? So now we should build a Docker container from our application. And what's nice thing about Micronaut is that we have the Docker support integrated in our Gradle and Maven plugins. So if you will now just go to some terminal where you don't have running this or kill this one.
I will stop this.
Yeah, and if you will just call Gradle W Docker build, then
just that
Docker build.
Right. Okay.
Yeah.
Right. So it created a Docker file.
Oh, we are automatically able. Yeah. We are using Gradle Docker called Gradle. So with slight changes, right? Because we are trying to Micronaut to provide the users some defaults, so you can very easily start using, for example, Docker. So now you didn't have to do anything, and you are able to build a Docker image. But because we will be using, Docker in Kubernetes, it would be nice if we would be able to push the Docker somewhere, so the Docker container somewhere. So now, if you will go to your build Gradle file, we will configure.
Right. I will open this project in my IDE now. So I'm using this virtual machine, right? So I'm gonna use the projector thing by JetBrains, and what it will do, it will start me an IntelliJ IDEA instance on that cloud machine. And I will connect to that through the client application. You can see that it looks like this. It looks a little bit like this. So there is a handshake and it connects through HTTPS. And now it renders my UI here in my application. Let me just create this, make this application a bit larger and a bit smaller. I can application, right? And let's go into the presentation mode so we both can see what is happening. So we both can see. Yeah, very good. Presentation mode, we both can see what is happening.
Yeah, so let's get back to that build Gradle file.
Yes, so build Gradle.
Yeah.
Right.
Now just add a Docker build task, basically.
Right, 1 second. I think something is struggling. I should maybe not either do this before or not do this this often. Right, 1 second. Let me give me a moment to just create the thing, right? So I will, for the sake of speed, I will try to wait a second.
Well, maybe you want to restart the project a bit because it doesn't behave normally, it's a quite small project now.
Yeah, maybe we can try this projector. Wait, let's do the vi build Gradle while this. I will go easy on the thing, and we're gonna create the Docker build, right?
Yeah, it's the Docker build task. Yeah, with images variable inside.
Right.
Okay.
Let me just. So here I do images, right? Because I want to configure the images, and I do just the my name here,
array,
right?
Yeah. This is the name of your like your Docker Hub registry, right? And yeah, exactly. It's like
I think something like this, right? So
yes. You can basically put here more images. Depends how many images you want to build, right? Yeah, normally there is like a latest tag, version tag, but this is enough. So now, if you will go and do right, if you will save this file,
right, and I do Docker build again, right?
Yeah, we can even call directly Docker push. What will basically cause the Docker build will be run as well, but we will also push it to Docker Hub.
Right.
And of course, you can use any other Docker registries. It's not just about Docker Hub. We are basically taking the credentials from Docker configuration. So, okay. So now we have pushed the Docker image to Docker Hub. So now we have the image, we have the application. Now we will.
Wait. Let me see. Docker Hub. I'm suspicious. It was too easy. Docker Hub, right? If I just click there and go inside that, I want to see that image in the Docker Hub. Because that was kind of cool. I mean, I know that my Docker, on the command line, I have the Docker, right? And I did the login, right? So it connected to the Docker Hub. I had to do that before, but you can see, yeah, the demo application was updated just a minute before. So that's kind of cool. How big is this? How big is this image? How large it is? Do you know?
Well, I would say a few 100 megabytes.
Yeah,
but the application itself won't be huge. You know, the application itself will be quite small because we don't have much there yet.
Right. Okay. Sounds about right. Here's our projector again, right? It's a little bit more responsive. Okay, so we built the Docker image, we pushed it to the Docker Hub. Now we need to get it into the Kubernetes. So I feel like I would be writing some YAML right now.
Well,
I know that much.
Not exactly, because yes, you right. For Kubernetes, there is lots of YAML files or JSON files that you have to manage. But for our case, you know, we will ease these things a bit. That we will use decorate. Decorate is basically a collection of compile time generators, and of course for Kubernetes that will help us to generate these manifests instead of writing them manually. So we can have the application code and very simple declaration of how it will be deployed to Kubernetes together. I know it's not usable for some maybe critical services, but for our case, to just very quickly create an application and deploy it to Kubernetes, it will be very, very, very handy. So we will add first this decorate and annotate our application, and then we will deploy. We will let the decorate to generate the manifest, and then we will use those manifests to deploy our application to your Kubernetes cluster. So first, let's start by adding dependencies to decorate. So go to the build Gradle, yeah, we have it there, and to dependencies task, and add an annotation processor.
Oh yes, annotation processor. Okay, that was easy, and that would be IO Micronaut.
Now it's decorate. So IO decorate,
Right.
colon. Yeah, and now it's Kubernetes Annotations.
Annotations.
And
Annotations.
yeah, and at the version like 2.1.1 is the latest version.
Right. Very good. Very good. IO
And
decorate
now,
Kubernetes annotations. Very good.
yes, and added there also the same dependency as implementation. Right. Cool.
Oh yes. Right. So that will allow us to have the decorated as a dependency and also configure that as an annotation processor. So
yeah,
we're gonna slap some annotations on our classes, and the decorate will use those to generate YAML for me.
Yes.
Oh, that is neat. That is very neat.
And one more thing, we will add one more dependency for Micronaut management. It's a module that contains like exposed health and health basically endpoint. This endpoint is very handy for use in Kubernetes because maybe you are aware of that there's something like liveness readiness probe, and based on these probes, Kubernetes decides about the life cycle of the container. What means that basically when the readiness probe is like successfully executed based on this configured policy, then Kubernetes starts sending traffic to the container. And very similar it is for liveness probe, when based on the results, the Kubernetes may decide to restart the container if it's not responsive, etc. So now, and this is basically everything that's packed in Micronaut management module. So now let's go to your application Java file.
I know. I will change this thing.
Oh yes.
But
yeah.
Let me explain
it.
Yeah, you can explain it.
Never mind. I don't.
Literally, there is one issue with the decorate thing that we discovered just before we were trying the sample project before, and it's about how it parses the versions and everything. So we need to change those to the single quotes. For the love of anything that is saint, I don't understand why, because it's supposed to be just a string, but it works this way. So it's probably going to be fixed very soon, but for now, this is the thing that we need to do. Right, so we wanted to go to the application.
Sure, yeah. Okay, and now we will add the...
I'm gonna refresh the dependencies. I see that, and I'm gonna load the Gradle changes. Right, so far quite smoothly. If you have any questions in the chat to Pavol or me, but I know a little bit less about this Kubernetes integration, so yeah, go ahead.
Okay, so now let's add those annotations. So start by adding annotation named Kubernetes application.
Yes, so we make this application and create. I'm just very upset about the performance of this thing right now. Right, I'm gonna VI it. Source.
Good thing that you have 100 gigabytes of RAM, right?
Yes, I will run my. So here I will do at
Kubernetes
application. This is a little bit very hand wavy, but we're gonna try to do this. And I know there is a bunch of stuff that we need to put in.
Yes, also let's do not forget to imports, right? So first let's configure the name of this, because this will be the name of the service and this will become the name of the deployment. So let's configure the name field.
Right, so okay, name. I don't feel like this will be the most convenient. We're gonna call it demo, right? It's a demo application. We're gonna call it demo.
Then let's configure the ports.
Okay, ports. And
That's at ports. It's a new object basically, so you have to configure it at ports.
Oh, yeah. So it's another annotation, and
configure the name, like for this annotation for this ports.
Right. Something like, something like this, right?
I hear a lot of clicking, but nothing. Okay.
Oh, look who's talking. Right.
Oh.
I'm gonna copy this part like very simply, because I don't feel like doing that in VI, and then I'm gonna do the opposite, right? So we're gonna change the image pool policy, right? Can you explain what that is?
Yeah. Image pool policy basically a strategy how the Docker images are basically pulled from the registry. There are, three known policies. One is always, which means every time the deployment restarts or new pod is spawned, then we are always trying to pull the image, then use the one that is on a local Docker registry. And this is the policy we will use, because we will restart our pod several times, so we don't have to increase the version or do some other magic. Then we will use this policy. Also, we configure the liveness and readiness probes like mentioned previously with regards to the Micronaut management module, and this will basically, and we will check it later in a while, this will basically generate the service and deployment Kubernetes manifest. But before we will continue, we will add one more annotation that will help decorate to evaluate the correct name of the image, because obviously decorate is not integrated now much into the Micronaut, but I will promise that I'm promising you and all the guys in a stream that this will change very soon. So now add annotation at Docker build.
Let me just do that. Docker build like that.
Yes, like that, and configure the field named group, which basically says like group. Yeah, let's start with group.
This is me, right? Group is my name.
Yeah, and let's configure even the Docker image name again to demo. So name
demo. Very good. Is that it? Should be it.
Yeah, is that it? And now we have to copy here of. I will tell you what
the imports. Let's do this. There are a couple of questions in the chat, and I want to address them, and I want you to address them as well. So thank you for the questions. I see them. I promise that I will find a moment to ask them. So Marianne Trapp is asking how secrets would be managed with this Kubernetes integration. So if you can go into maybe the secret management a little bit for like half a minute, I will restart my projector and try to get the imports done.
Yeah, well, secrets are basically injected as any other properties. There's no much deal to it, right? We take the secrets, we decode them because by default they are encoded in resources. But of course, you need to the application needs to have correctly configured the role access binding, right? Because so the account, the service account under which the application is running needs to have the ability to read the credentials in the namespace from where you want to read it. But once this is there, you can basically inject those secrets. You can specify which secrets you want to inject, and those secrets will be injected because it's just purely about then how the secrets are structured in your secret Kubernetes manifest. If you will check our Micronaut Kubernetes documentation, there is a whole place paragraph, huge paragraph actually, that describes how to achieve this, right? At first, this feature needs to be like specifically enabled, because it's not something we want to like enable by default. And once this is done, you can either inject all secrets, or really you can include or exclude some, or you can select or filter the secrets based on labels or based on pod labels, because pod labels are used a lot when using a Helm charts. So you can do this as well. Plus, if you wouldn't want to do this thing, you could, because sometimes, the applications doesn't have the permissions to read secrets, right? Because it can be quite, risk to let applications read secrets. So there are times when the secrets are mounted as volumes. So this is possible as well to use in the Micronaut application. So in the guideline, you will find out how to basically read secrets that are mounted as a volume. So you will just specify path in the container where these secrets are mounted. So that's it.
Right, very good, very good. Saurabh is asking, can we have application read ports and other values from the environment? I assume that is configuration about the configuration of the things.
I think I don't understand. Whether could you read once again, please?
Can we have the application read port and etc. from the environment?
You mean like you would configure the port of the application where it will be started? Well, I think it's possible. Why not? We will for the port binding. Actually, you can use Micronaut, expression language for configuration, when you can declare the port, or you can declare the environment variable with colon and declare a default port. So yeah, that should be possible actually.
Right. Yeah, I would assume so. The application gets deployed in the pod, right? And that pod is actually a Docker image. So you can read configuration there. And just now, a little bit later, we're going to show how you can read the configuration from the config maps in the Kubernetes cluster, right? So I assume that with the combination of those two, it should be like a quite straightforward task. And
it's a bit of combination. Maybe what you said or asked. Well, there can be a problem these Docker, the Docker ports maybe have to be exposed, so you should have where where is this application running, what's the port binding. What I'm not sure it is, so I would have to try, but I never basically was dynamically changing the port number in Docker containers, especially in Kubernetes, because this is basically something that's quite abstracted in Kubernetes. You can reuse the same application with the same port, and the difference is just that you are exposing it on different exposing services on different ports, etc. So maybe I would need to know more what's the merit of the question.
Right. Very good. Thank you. And Vila Jonah is asking, is this decorate? And this one I can take. Yes, this is decorate. Those are the annotations from the decorate project. And now they're imported here. They're here. So now we can maybe see them in action.
Okay. So go to terminal and run GraalV or GraalW compile Java. What should generate us the Kubernetes functions?
Right. So I do GraalW compile Java. That's the most obvious target to run. I
think you have some issues there with syntax.
Load file system changes. Oh, come on. Let me just import the classes again. See, this is don't laugh at me. On the last stream, that was such a funny situation. It was when I was using the VI in the terminal in IDEA, right? So in the integrated terminal, and then the projector wouldn't send the escape correctly, so I was stuck in VI and I couldn't exit. That was just the classic rookie mistake, and I had to close the terminal window to get exit VA. Right, so we processed that, we generated some files. I see the YAML. Let me just go and open that.
Yeah.
let me just quickly. It sits in the build, so which is like a little bit unfortunate. Classes, and you can see there are a ton of things in there. Meta-inf, wait, no Java, meta-inf, what? Classes,
yeah,
Java main, what? Classes, Java main, meta-inf.
This is Java main meta-inf. Maybe
decorate
didn't pick the
this
change
is the wrong
of the
decorate.
file
This is
directory.
decorate.
So maybe, yeah.
And the thing is, like, by default, this is not the best location, I would assume, because those files are ignored by the version control system. I don't know. I'm not 100% on board with the location, but I like that I didn't have to write this file by hand.
Yeah. The location will be unfortunate, but actually it follows what it did, right? Because this is delivered like as a result of some processing, and the source of truth is basically the annotation and not the YAML file. This is basically an output of some processing. So, but yeah, it generated a service and it generated a deployment and decorate supports, even generation of other things, not just the Kubernetes manifest, but there's an OpenShift, there is a Tecton, there is a lot of other stuff. So feel free to check it.
Right. So we have a service, which is our application in Kubernetes terms, right? And we have a deployment, which is a deployment?
Well, deployment is through deployment, you tell the Kubernetes like how to create and modify instances, how to deliver new, a new version of containers. It basically manages two important objects, replica set and pods, and it's kind of an abstraction on top of these two like Kubernetes resources.
Right. And the pod is the instance of our application, right? So this is the sort of the container that we can start.
Not many people knows, but it's an acronym for point of deployment. Actually, yeah. It's
very good.
Point of deployment.
Right. Okay. So we have the YAML, and we can apply that YAML, right?
Yeah. Let's do it. Let's see what we will do.
So we do kubectl, and then we apply.
kubectl.
I can show you. See, there are no pods. There is nothing running in my cluster, right? So if I do kubectl, and then I apply, and I give the file, and I just need to give this file, right? Copy path from the content root. And since we are here in the content root, so this is the build classes, everything, all good. We apply and we created the service demo and deployment apps demo in our Kubernetes cluster.
Yes. Now check whether the pods are running and started.
Right.
So we have just one pod. Right?
Yes.
It's getting started. Cool.
Right. So minus like -w will make it continuously monitor this and output when the status changes, right?
Yeah. Funny, the status is not changing, right?
Yeah, it is funny. Like, it's not that funny. It's not like haha funny, but like it's more like funny as in interesting.
Yes. Well, let's check what's happening there. So run kubectl describe pod.
Describe pod. Wait, one pod, right? And I need to do the ID.
Yeah.
Okay.
Our probes are failing. Well, something's happening inside our cluster, inside our container. So let's investigate why is that happening.
Right. Can I do logs?
Yeah. Let's do logs.
Oh wait, I copied something. Right. So we have this container. I will copy the ID and we'll do kubectl logs demo application. The application has started.
Interesting.
The application has started, but we don't have the readiness probe available, or something didn't run correctly.
Yeah, let's execute into the container and call it ourselves. So we will see what's happening there.
Here's an idea. Pavel. So tell me, when we applied those things, did we have to rebuild the Docker container and push it to the Docker Hub?
Well, we did not. Well, that's a good point. So yeah,
I think I'm onto something.
One guy.
So we need to do Docker push.
Yeah.
Right. So
Well,
we do Gradle W Docker push, right? Because that will build our application with the Kubernetes configuration and the readiness probes and everything, and it will push it to the Docker Hub, and then the Kubernetes cluster will pull that from the Docker Hub and deploy that. And hopefully that one will have the probes configured.
Well, I hope so. Well, I hope as well.
I mean, I'm very proud that I got this before you got this, so I'm very happy with the stream today. Somebody complimented the setup and the music as well. Thank you, Villadrona. I'm indeed extremely happy with this. Right, so do we need to reapply this?
We don't have to reapply it because we didn't change the manifest. We will just restart the pod. So just run kubectl, rollout, restart, deploy,
and deployment demo.
Yeah.
Right, very good. So how do you manage those commands? Do you have like a series of bash scripts, or do you have like?
It's just when you run it like 1,000 times, it's just like some some poet or something like that. It's like a poem, right? You just learn it and you will remember it until end of your life. So yeah, just a habit.
Okay. So we restarted.
Let's check the pod whether it started.
Yes.
We'll see. It's ready. We have to restart. That's interesting. What's happening? No. Okay, so that's not the one. So it's terminating, and now our one is running. So if you will run it without the W, we will see there just one pod. Great. So now let's try to and call it, right? Oh, we are quite late. So maybe we will finally add the discovery. Okay, we will go and proceed, and we will find we will add the configuration discovery. So first of all, go to the build Gradle and let's add finally our Micronaut Kubernetes discovery file.
Right. So I just go to the build Gradle file, and this is now the first thing that actually makes Micronaut and Kubernetes kind of know about each other together, right? Because before actually,
in Micronaut we know. Well, that's nice about Micronaut. You don't have to use a bunch of dependencies to deploy the stuff somewhere, right? By default, it will run because we have the plugin, and through the plugin we are configuring a lot of stuff. And now we will add finally something that we will use for the integration. If you don't need those integration, you don't need this module. So yeah, we have the dependency. That's great. Refresh the dependencies, and let's proceed to the controller.
Right, it's scanning something. It's never been a problem before to scan like various things, but today it's scanning. Right. It also shows me that my internet connection is unstable, so which is on me. But it was good before. It was decent before. We tried that. So let me just very quickly. I don't know why it's happening like this. Right. So but I'm gonna just do this. I blame Gradle, to be honest. Like this happens with Gradle.
Yeah. Sure.
I don't know. Like something is just not 100% correct with the setup. Let's see. It's starting the connection.
Until it's not Micronaut, I'm okay.
Yes, of course. It's almost like we're back. The dependencies are there, and we can also go to. Oh, we don't need the application, right?
I don't think the dependency is there. Is there? Are you sure?
Yeah, I'm pretty sure. Like that's
okay,
the
so
what? No. Go back.
Well.
right? Go back. We need the example controller, right?
Yes. Yes. Let's go to the example controller. And let's tweak it a bit. So the controller will return the, injected properties that we will be downloaded from config map. So let's add some new endpoint. Let's call it like example.
Right, so we're gonna just have a new method here, right? And we're gonna map it to config, and the parameter, we will take the key of the configuration that we want to return just for demo purposes. And we're gonna take the application context and then get that key or return nothing if there is nothing by that key, right? So, and then what I need to do, I just need to do the application context. I need to create like a field that for that. So just, I know that context. That was a surprisingly, see, like, I think this is my internet. I'm very sorry for people watching. I hope you actually get the, like, not a jerky stream, but like a normal, what?
Oh.
Right, this is on me. Wait a second. Right, we gonna see. Pavel will temporarily not see anything, but hopefully everyone else will see everything. Inject. See, now I'm like a professional racer. I can type things and they show up immediately. I blame Zoom now. I don't even blame Gradle. So we inject the application context, and we have this configuration file here, right? What next do we need to do? We need to create.
I don't know where you are, but you need to edit you need to annotate the controller by refreshing.
Okay, that makes sense. Refreshable. I have the refreshable here.
What refreshable, just for the listeners, what refreshable about is that this makes the bean like listen for the refreshes that happens inside the application and in context, right? So once there's something changed, this bean will be like recreated. That's one thing. And also you can, configure the listening for very specific properties. But well, let's have it this way. So now we are having this configuration, and now.
Right, now we need to create a file, right? Where we're gonna enable the config client.
Well, first we need to, enable the config client. Yeah. So let's create a Bootstrap YAML file. What's the Bootstrap YAML file? Well, if there's a Bootstrap YAML file on a class path, then the Micronaut will create a very tiny and small bean context just for the purpose of obtaining some, additional data to spawn and create the final application context. So this, right. And by this Bootstrap YAML, we are basically saying like, okay, config client, you put it already there. So by this, we are saying like, when this is the enable or configuration clients, and we have one in Micronaut Kubernetes module, and that will basically download the config maps. And if there is some, demand for some specific properties for, creation of beans, or etc., then Micronaut will use those properties from the Kubernetes. So yeah, we have this thing ready. And now what we will do, let's go and let's create some config map. And so let's go back to the terminal and let's create, or maybe first build Docker image. So we have the Docker image ready.
Okay, that was Gradle Docker push. Docker push.
Oh, Gradle W. I don't know whether you have Gradle there.
No, I don't. Right. So, and to be honest, so Docker push currently pushes the Docker Hub, but it can be any Docker registry, right? It doesn't have to be Docker Hub.
Yeah. Just place it whatever you like. You can put there like a complete, URL to your private registry. It's up to you.
Right. Okay. So we are done with that, and then we need to create the config map.
Yeah, let's create a config map. So let's create it from some YAML files. So create a new YAML file here, like example or demo or whatever.
Okay. Okay. And I just put my configuration here.
Yeah. Someone is connecting to this Zoom actually.
This is fine. Just people who are connecting to Zoom, please don't like. you can be here as a voice, but let's not interrupt a lot.
Okay, create some simple property here. Okay, like I don't know.
Okay, enemies, and I will do cheat, and I will do level, right?
Yeah.
And we're gonna do it here. Hello, world.
Yeah.
Because I'm not excellent with the configuration things, right? That is a YAML. I think this is a valid YAML, right?
Yeah, seems.
So that's my config, right? And that's my local file. I also need to put this file into the Kubernetes.
Yeah, yeah. So now just type kubectl create config map.
Config map.
Config map. Yeah, yeah.
Okay, every resource in Kubernetes, I need to give names, right?
Yes, every resource has a name.
Right. Okay.
Dash from file.
Okay. Yeah. I recognize and I do the file, right? So now we will instruct to make that config map in the Kubernetes. So now, if I want to edit this, I would do kubectl edit config map.
And you can even use if you want to, save some time. You can type just cm like a shortcut for config maps, like cm, and demo config map.
Okay. So now we don't need the file, but it's right here, and it's incorrect, right? It's like weird.
No, it's okay, I believe.
Are you sure?
Well, I think. Well, there are.
Okay. You're the Kubernetes professional here, so it's.
Oh.
If you say it's okay, then.
Okay, and now let's go and restart the container because we already pushed it. So it's kubectl rollout.
I don't think this is correct.
Yeah, I think it could be okay. We'll see very soon.
Okay, so I do rollout restart, right? Kubectl rollout restart.
Yeah, restart.
Deployment.
Yeah.
Demo. Right. Restart. Very good.
Yeah. Now let's check the logs of our kubectl of our. Okay, starting. So go and check the logs. So kubectl logs and no get without get. Yes.
Yeah. And we take the new
one. That one. No, that one. That's the new one.
The new one here. What I can see here that it resolved configuration.
Yes, from two sources, and one is definitely our config map. So now what we have exposed that through controller. So now let's port forward our service so we can call the service from localhost.
Right. So let me just verify that I understand correctly here. So the configuration got into the context, right? And we're gonna expose this, and now we're gonna try to access this URL here.
Yeah.
And to do so, I need to kind of get a tunnel from inside the Kubernetes cluster to the outside, because I'm on the outside, right? So I want to access it from the outside. Internally, it has some like an IP port, and like the port's open, and it's all managed. But from outside, I need to kind of run a command to get that. Okay. It's kubectl. I know kubectl. Port. Double dash. No, one dash.
No, right, no, just. And now just service / demo 8080 :80. Yeah.
Right. So we forward the port into that service, and this is our local machine.
The other way around. We forward a port from the service to the machine. But yeah.
Right. Okay. So, but 80 is the internal port, right? Because That's
80
the port.
is the port of the service where the service is running, like in Kubernetes, like the port of the service. And 8080 is your local port. Because
I see. Open HTTP client. We can see that configuration. Enemies of the state. Enemies. What was it? Cheat level.
Yeah, and you have to update the port as well. Yeah.
That was 8080, right? Okay, so gonna run it. Hit it. All right, we see the hello world back here. That is actually quite spectacular. That is actually quite spectacular. Because for some reason I didn't expect this to work on the first try. Right. Okay. So can I edit this now? Right.
Yeah. Let's try this.
If I just quickly do the edit.
Yeah.
Right. So
and maybe this is very unfortunate format of the YAML file.
I mean, yes. Let's do this properly.
Because no, right? It just escaped the new. Okay.
Right.
Okay. Let's try.
Be fine.
It should be fine. It should be fine. If we have the right amount of spaces there, but let's hope we have.
Enemies cheat. Right? Was it cheat?
Yeah. Level.
And then we had this here. It was Hello World before, and we're gonna have long live Micronaut.
Okay, but I don't know what. Well, you created basically new object there. You didn't change the level. There's one more, new line. So in between level and long live the Micronaut, you created another, level of another.
Right.
Level.
Okay. I'm here. I'm professional in VI, so I can just do this. Right.
Yes.
This is perfect. I don't know why it shows in that format. Do I need to do anything else? So I edited my config files, right? And now, because of the refreshable annotation, I assume that it will be picked up automatically.
Yes.
Okay.
We can try this. This was some, amount of time in between when this is propagated, but let's try.
Yeah. Oh my god. We see the long live Micronaut. We see the changed values. So that means that configuration change was picked up, and the Micronaut reloaded, that being recreated, that being to note that there was a configuration change. Right.
Yeah. Normally, what you do normally is that you have the application YAML file with some configuration, but you will take this configuration from this application YAML file and externalize this configuration to the config map. So that means that if you have like 10 instances of the same service, you can manage the configuration from one place. So that's what it is basically for. So that's it. But I think we don't have much more time to present like the service discovery. So if you like, we can leave it for the next time, and we can continue building this service. So we can present the service discovery, and maybe, or why maybe, we can also present the secret discovery if there was a question related to it. So I'm open for do this.
Yeah, I think that is a good plan. We are currently indeed at the top of the hour. So we showed the configuration discovery. I'm very happy that actually in the end it all kind of worked out, because before it was struggling a little bit with the internet connection. I'm very grateful for you, Pavol, for joining me here and also preparing this demo application for me and the explanations. I feel myself more comfortable with Kubernetes and at least the basic deployment steps, right? I understand the concepts a little bit more, and I'm sure that the service discovery would work in a similarly straightforward manner with some sort of web client. We should do a session on that eventually, but at this time, I thank you very, very much, and I think we will wind this down and start moving towards the next session. Do you have any questions for Pavol? Maybe we can take a minute out of the next, if there are questions in the chat. I don't know if we do have questions in the chat or not. Currently not. There are some people thanking you. Thank you, Moran, for the kind feedback. It was interesting for me as well. Yeah, and we'll do those demos further. Maybe on this application, maybe a little bit on a different use case.
Okay. Thank you, Oleg. Thank all the guys on the stream, and see you next time.